Hello and welcome to our quick presentation and demo of multi-cloud connectivity. Here is a challenge which underlies our functionality. If a distributed application has components across two different clouds, for example AWS and GCP, how do those communicate, or how do we get those to communicate? Our answer is via an instance of what we call connectivity across those clouds. Now, what do we mean by connectivity? An example is explicated by the upcoming demo. So in our demo, we have a virtual machine or virtual server in AWS and one in the Google Cloud Platform. We want them to be able to communicate, and as per AWS and GCP, a de facto way of enabling such VMs to be able to communicate is to contain them in virtual private clouds or VPCs of their own. So as this picture at the bottom shows, we assume that a VPC has been set up in AWS within which the VM is housed, and similarly in GCP. Now, that is not enough for the two VMs to be able to communicate. So really what we need in addition is to carefully configure a number of things for any VM in the one VPC to be able to communicate with a VM in the other VPC. And here is a quick list of some of the things that need to be configured. And I should point out also that there is really a dependency amongst these components, meaning that chronologically some of these components need to be set up and configured correctly before another component. So it is really somewhat of a nuanced and painstaking configuration which lends itself to automation, which is exactly what our software achieves. Moving on to the demo. Okay, so here is the front end of our software, and if you watch our demo of the graph database, then it's you've seen this before. And what we have to the far left, the two console screens, one is just the running logs of what's happening behind the scenes of our software. The other one is a console to the virtual machine or virtual server we have to the AWS instance that we will be using for this demo. Now, the first thing we need to do is to let our software know what the VPCs are that need to be connected, and a way to do that is to upload a YAML file which describes the VPCs, and we have set up exactly such a YAML file, which is called connectivity.yaml in this demo. And as I said, this YAML file tells our software what the identities and the characteristics and how it can locate the VPCs, because our software has to be able to communicate with the respective cloud providers so that it can do the configuration. Now, as you can see here, now that I've uploaded the YAML and mounted it, there are three vertices that show up. These three vertices correspond to VPCs in each of Azure, AWS, and GCP. Now for the demo, we're going to focus on only the VPCs of AWS and GCP. Obviously, if you've seen the graph demo, then you can click on these nodes and look at their attributes and so on. And you will see that they correspond to VPCs in each of the clouds that I just mentioned. Now, obviously, for the purpose of the demo, I'm also showing you here the configs. So I've windows into the configs in each of the GCP and the AWS accounts to which the VPCs for which we are provisioning connectivity correspond. And one of the things you'll notice is that there really is no configuration that allows the two VPCs to communicate, VMs in those VPCs to communicate. And we can double check this. We can confirm this by doing the ping test. So what we can do is copy the IP address here on the GCP side and issue a ping on the AWS side, meaning within the console that we have here to the far left, which is to AWS. So let's try that and see what happens. Okay, and unsurprisingly, the ping fails. And this is because those VMs are completely isolated from one another. And as I said before, we can always go into the configs, and in the context of this demo, there is nothing in the AWS and GCP configs that will allow those VMs to communicate. So now what we're going to do is we're going to exercise our API, and we have hooked up some basic elements in the front end to establish the connectivity. So we are able to, so you see to the far right, it gives you a little menu and for the VPCs for which we're able to provide connectivity. And what we can do is we can go in and connect them. So here I just sort of am scrolling through and pointing out that some of the configs we need, gateways, for example, are simply not there on either AWS or GCP. So that was AWS, and now this is GCP. And we do have some resources that we had deleted previously, which of course this is how these cloud providers operate. When you delete some resources, they don't immediately disappear from our list of resources. On the Google side, things are a lot cleaner. All right, so now why don't we go back to our software and provision the instance of connectivity. And just to make it easy for this demo, we have hooked things up in the front end. So all we had to do was click a button after sort of highlighting the nodes that need to be connected, or identifying the nodes that need to be connected, the VPCs. So you see that an edge appears immediately, and the reason is we maintain an internal state machine with the status of the instance of connectivity. So for example, we can click on that edge and look at the attribute, and you can see that the state is that it is connecting, meaning it's not connected yet. I mean, if you have any familiarity with these cloud providers, then you'll know that it takes quite a bit of time for them to configure. So what we're going to do here is do a little bit of a time lapse, and because we don't want to be waiting for 20 minutes. Okay, so after the time lapse, it turns out that the connectivity has been established, and we can confirm that from our log messages there. We can also go in and click on the edge now once we have refreshed our window, and you see that the state has changed to connected. So our software monitors the instance of connectivity and changes the state to let the user know that connectivity has now been established. Now if we go and look at some of the configs in AWS and GCP, we'll actually see that we've gone in and configured the gateways that we need. One can go look at the route table. This is the virtual private gateways and site-to-site VPN. These are some of the configs that are needed for the connectivity to be established. Similarly, on the Google side, we hit refresh. We should see a bunch of configs. So VPNs, gateway setup, route tables configured. So I'm not going into detail on some of these, what the configurations are that are needed in this demo and presentation. Okay, so now let's do the ping test between each of the Google and the AWS VMs that are resident inside the respective VPCs. So let me launch a console to the virtual machine on the Google side. We already have one for AWS. Okay, so I copy the IP address. On the Google side, of course, that's a private IP address because it is an isolated VPC. I'm sorry, yeah, so the IP address for the Google side, and then let's use TCP dump on each side to check that we are actually able to see the ICMP traffic. So that's TCP dump on the Google side. Okay, TCP dump has been started. TCP dump is of course just a packet sniffer and protocol analyzer. Now, if we ping from the AWS side, we can see that we are successful, and on the Google side, we see the for the TCP dump output. We can repeat the same thing the other way. So we go grab the private IP address on the AWS side. Let's start TCP dump on the AWS side. These are, of course, Linux VMs in each of Linux instances in each of AWS and GCP. Okay, so similar thing as we saw before, except this time in the other direction. So indeed, connectivity has been established between the two VPCs, as evidenced by the fact that the VMs in the respective VPCs are indeed able to communicate. Now, going back to our front end, we've also hooked up, to make it easy for the user, an easy way to disconnect, meaning removing this instance of connectivity. And as we see here, all we have to do is highlight the edge and then click disconnect. And that's going to go in and remove all the configs that the connectivity provisioning establishes. So that's it for the demo, and thank you.